All right, good evening, everybody. We're going to talk about dilations around any point. So dilations around the origin and dilations around any other point. So I'm going to skip a little bit of this here because dilations on their own are not that hard. So for the rule for dilations, essentially, is that if you're dilating around the origin, x comma y, you just need to multiply each of the coordinates by your scale factor, which I usually use a k to represent my scale factor, but in the notes we have an n. Now, if your scale factor is larger than 1, the image is going to get larger. If the scale factor is between 0 and 1, your image is going to get smaller. So first let's take a look at one that is centered at the origin. Okay, so if we look at where A, B, and C are, A is at negative 2 comma 0, B is at 2 comma 1, and C is at 3 comma negative 1, then we can come up and by the way, when you read this notation, the D means it's a dilation, the 2 means that it's a dilation by a factor of 2, and the O just means that it's a dilation around the origin. So this is just a notation that you might see sometimes. So the idea here is that since the dilation factor is 2, everything gets multiplied by 2. So both of the coordinates get multiplied by 2. So we got negative 4 and 0. If you do the same thing for B, you get positive 4 and 2. If you do the same thing for C, multiplied by 2, you get 6 and negative 2. And so we'll do that. Negative 4 is 0, so our A prime, let's get a different color here. Our A prime, negative 4 is 0. 4, 2 is our B prime. And 6, negative 2 is our C prime. So if we connect these points, we have a dilated image. Now something that's important to point out here is that if you look at if you compare the distance or the lengths of corresponding sides, because the shape did not change, the ratios between the sides are going to stay the same. So for instance, if AB has a length of L, okay, we'll just say it has some length, then because the scale factor is 2, then A prime to B prime would also have a length of 2L. Okay, not only that, but the points themselves will be scaled away from your center of dilation. So we use the origin as the center. So for instance, if you take a look at A, how far away A is from the center of dilation. It's 2 units away from the center of dilation. And if you look at how far away A prime is from the center of dilation, A prime is 4 units away, exactly twice as long. So no, the scale factor also will tell you how far away something should be from the center of dilation. Because A is 2 units and A prime is twice the length or twice the distance from the center of dilation. It is 4 units instead of 2 units, so it's twice as far. And the same is true for all of the other ones here. These are a little bit harder because you would have to use the distance formula to determine them, but that's just something to keep in mind when you're doing dilations. All right, now the ones I really want to take a look at, and you can see some more examples here on the other pages. The ones I really want to take a look at are the ones where we have to dilate around a point that is not the origin. Okay, so if you look at this one, it says, given the figure below with the center of dilation and a scale factor of 2, find the image. So the scale factor is 2, but if you look here, we're not dilating around the center, we're dilating around this point right here, which this point is at negative 4, negative 9. Okay, so how do you do this? Well, you do it the same way that we did rotations that were not done around the center. you perform a translation first. So we translate this back to the origin. So how do you translate this point back to the origin? You move it to the right 4, and that will move it to this way, and then you move it up 9. Let me get a line here so it's not as messy. You move it up 9. Okay, so what we're going to have to do is translate all of these points right 4 and up 9. And you can do that by just adding 4 onto each of the x coordinates and adding 9 onto each of the y coordinates. So A is -4, -6. B is -2, -1. C is, what is that? 3, -6. Okay, so I'm going to add, so A prime, B prime, and C prime. So I'm going to add on 4 to each of these units, their x coordinates, so that they move right. So if you add on 4 to this one, you get 0. If you add on 4 to -2, you get 2. If you add on 4 to 3, you get 7. And then I'm going to add 9 to the y coordinate. So the y coordinate is going to increase by 9. So from -6 plus 9, that would be 3. -1 plus 9, that would be 8. -6 plus 9, that would be, what? 3. That would be 3. Okay, so these are our translated points. Now that these points are translated in the same way that the center of dilation is translated, we can perform our dilation. So the next thing I'm going to do is I'm going to perform the dilation, and I'm going to multiply each of these by 2, the x and y coordinates by 2. Okay, so for the first one, multiply by 2, you get 0, and you get 6. For the next one, you get 4, and you get, what is that, 16. And then for C double prime, you get 14 and 6. Okay, the last thing to do is move everything back. So we translated right and up to move these to A prime, B prime, and C prime. Then we did the dilation. Now we're going to have to move it back. So right now, the center of dilation is at the origin, but we're going to have to move it back. So we're going to have to move it back to where it was. So we're going to have to go down by 9. So we're going to have to subtract 9 from all of our points. We're going to have to move it left 4. So we're going to have to subtract 4 from all our x coordinates. So all the x coordinates get subtract 4, and all the y coordinates get subtract 9. So if you do that, let's just do the x coordinates first. So the x coordinate, so 0, subtract 4 for the x coordinate, it moves to -4. 4, subtract 4 for the x coordinate, it moves to 0. And then 14 for the x coordinate, you subtract 4, it moves to 10. For the y coordinate, this y coordinate, we're moving it back down by 9. So we're going to move all of these back down by 9. So 6 moved down by 9 would be at -3. 16 moved down by 9 would be at, what would that be, 7? And 6 moved down by 9 would be -3. Okay, so now we have all of our points, so I can plot these. So I've got, these are the ones I want. This has been translated, dilated, and then translated back. So I got -4, 3. I got 0, 7. Oh, sorry, that's -4, -3. Sorry, I did that before. So that's -4, -3. And then I also have, so this is A double prime, what is it? No, this is B triple prime. This one is A triple prime. And then C triple prime is at 10, -3, so it's like right here. So C triple prime is right here. So now I can connect these points back. So connect here, connect here, connect here, and we see that we have a larger image, twice as large. The side lengths are at least twice as long as they were before, and you can count that. Like for instance, if you look at this one, or if you look at from A to C, it's 1, 2, 3, 4, 5, 6, 7 units across. But if you look at from A prime to C prime, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 14 units across. So it is twice as long as the original. And so that is how you dilate around something that is not the origin. You translate it just like we did with rotations. Okay? Alrighty, well, I hope that was clear. If you have any questions, let me know.